Hi everybody, this is TheGreenFrog here, and welcome back to another video. Today I'm going to be doing a math tutorial, and I'm going to be doing a tutorial on how to solve for a variable in terms of another variable, as you can see on the top of the screen. Now, just a quick little disclaimer before we begin. I am expecting anyone who is watching this video to come in with knowledge of how to solve simple multi-step equations. So if you don't know how to solve an equation, or if the most complicated equation you can solve is x plus 2 equals 3, then this video is probably not for you because you won't be able to follow along. I'm not expecting you to know crazy stuff, just simple two-step, multi-step, addition, subtraction, multiplication, and division, how to solve equations using those linear equations. So we don't need to know how to solve equations with exponents or anything like that. So now that that's over with, first I'm just going to talk about what it means to solve for a variable in terms of another variable. So when I say something like that, I'll give you an example. I mean an equation kind of like this. If you have something like this where it says a plus 6 equals b, just looking at that, if you have knowledge of solving equations, you know that's not like a normal equation you're going to see. Because a normal one you'll be used to seeing is one that only has one variable, like a plus 6 equals 10 as an insanely simple example. With something like that, you can just subtract 6 from both sides and get that a equals 4. Quick and simple. With something like a plus 6 equals b, though, because there's two variables and you don't know the value of each of them, you can't find a definitive, this is the only answer solution for the numerical values of both of those variables or even one of them. Because with something like that, there are infinitely many pairs of values that would work. Like if a is 0 and b is 6, then 0 plus 6 is 6. Or if it's 1 and 7, or 2 and 8, or 1,000,000.5 and 1,000,006.5, there's infinitely many pairs you can do. So you can't solve for a numerical value of both of the variables. What you can do, though, is if they say to solve this equation for a, or solve for a in this equation, what that means is to basically just isolate the a. So pretend that you could get a solution. Ignore the fact that you can't actually get a numerical solution. What would you do to isolate a? You would subtract 6 from both sides. So if you do that, we don't know what b is, but you can still say that a equals b minus 6 because that's literally just what you wrote right there. And in this case, that's actually the answer, because you cannot figure out an actual numerical value for a. When we say in something like this with two or more variables to solve for a, in this case, like you're solving for a in the equation and you're solving for in terms of b, that basically means that you're trying to get a on a side by itself. So even though it won't be something like a equals 7 or a equals 1/2, you'll have a equals and then some operations on the other side involving the other variables. So that if I was to tell you that b was 4, for example, you would not need to do a plus 6 equals 4, and then you'd need to subtract 6 from both sides and get that a equals -2. You could plug it in straight to this equation down here to save some steps, because you've already have a on one side. So you can literally just do, if we know that b is 4, you can literally just do a equals 4 minus 6, so a equals -2. You're just evaluating the expression. You don't even need to actually solve the equation. So that's what we mean for that, and that's an extremely simple example. So now we'll get into a few more complicated examples. So we'll start fairly simple. We'll just do something like a equals bc. Most of the equations I'm going to be using aren't actually going to be like actual equations that have actual meanings. I'm just making them up as good examples. So something like this, obviously a is on its own side, so they would not ask you to solve for a because that's done already. But if they wanted you to solve for c, for example, you just need to get c by itself. So you need to divide each side by b, and then that means that the b's will cancel, which means that you have a over b is equal to c, which means that c is a over b if you like to have the variable that you're solving for on the left. So that way, if you were to get the values of a and b, you would be able to figure out the value of c. So there's a simple example. Now if we were to have something like this, where if we were to have like a equals 2b plus 4, and you want to solve for b, then you just do it like you normally would again. So subtract 4 from both sides, gives you a minus 4 equals 2b. And then if you divide each side by 2, then you will get that a minus 4 over 2 equals b. Or if you like to write it the other way, b equals a minus 4, the entire thing over 2. And if you were to have something a little bit different, so if we change the equation at the top a little bit, and instead of having something like this, we're going to say equals b plus 4 over 2. Same thing, solve it as normal. Multiply each side by 2, multiply each side by 2. 2a equals b plus 4. Subtract 4, leaves you with 2a minus 4 equals b, or the other way around if you want to write it like that. Now we're going to try a few more complicated things. So this time we'll use the area of a triangle, which is a equals half base times height. And let's say they wanted you to solve for b, which is the base, so that if they gave you the area and the height, you would not actually have to solve for the variable. You could just plug in the other numbers and figure it out. Quick and easy. So if they wanted you to solve for b, then the first thing you would do is divide by 1/2. So if I divide by 1/2 on each side, that will make it cancel on the right, and a over 1/2 is the same as a times 2. So a divided by 1/2, keep change flip, is a times 2, so 2a equals bh. And then again, you're solving for b, so you need to get b by itself, so you divide each side by h, and you get that 2a, the entire thing over h, is equal to b. Or if you want to write it the other way around, like I said, feel free to do that. So there's another example. Now we're going to do a bit of a weird example here. And as you can tell, I'm not getting into anything crazy with this video, just for kind of like an introduction to stuff like this. So if I was to do something a little bit more interesting, like c equals 4 over b, and I wanted you to solve for b. Now, this is a bit of a weird thing. You might be saying, okay, 4 over b. If I was to want to solve for this 4, if that was like a variable or something, then I would just multiply each side by b. So maybe since you would multiply in the denominator, you might divide in the numerator. That might be your first instinct, which would mean that c over 4 would equal b. And if you try that out, let's say you say that 3 equals, no, that's a bad example. If you say that something like 4/3 equals 4 over 3, like that, and then you were to plug this in, 4/3 over 4 equals 3, that doesn't make sense already. You can tell that that doesn't make sense, because 4/3 divided by 4 is going to make it a much smaller number. It's going to be a third, and a third is obviously not the same as 3. So your first instinct there might be completely wrong. So if we were to change this to a much simpler example, it might be, it's probably not going to make it more obvious if you don't get it right away of what you should do, but it will make it more obvious why what I'm doing makes a lot of sense. So if you were to change this 4 to a 1, the interesting thing here, if you want to solve for b, is that you can take the reciprocal of both sides. Now, if you don't remember what a reciprocal is, it's basically flipping it. So if you have a fraction, you just flip the fraction. If you have something like c, then you're just going to do 1 over that, because c is really c over 1, and then you would just flip that to be 1 over c. So if I wanted to take the reciprocal of both sides, then guess what I would get? C is basically c over 1, so it becomes 1 over c. 1 over b becomes b over 1. Anything divided by 1 is just itself. Boom, that's it. That's all you have to do. Nice and simple there. So b equals 1 over c. And if we were to use another example here, like 1/4 and 4, you can see that it actually works this time, because 1 over 1/4 equals 4. 1 divided by 1/4, if I go down here, is the same as 1 times 4 over 1, which is 4. So you can see that that works. So now if I was to change this back to the equation that we had before, we can use a similar strategy to solve this. So if I was to change this, erase all this stuff, and then change that back to the c equals 4 over b, then I could take the reciprocal of both sides to get 1 over c equals b over 4. And then if we just multiply each side by 4, then we can get that 4 times 1 over c equals b, or that b equals 4 times 1 over c. And if we were to use our example from before of 4/3 and 3, you can see that this time it actually works, because we have b equals 4 times 1 over c. We have that 3 equals 4 times 1 over 4/3. Now 1 divided by 4/3 is the same as 1 times 3/4, and anything times 1 is just itself, so that's 3/4. So 3 equals 4 over 1 times 3 over 4, which obviously it does, because that's 12 over 4, and that is 3. So you can see that our new, if I just erase this stuff, now let's just check that it worked, just to get some of the clutter out of here. You can see that taking the reciprocal of each side is actually a fairly helpful strategy for doing a lot of these types of problems, where you actually have the variable on the bottom of the fraction. If you have like something over the variable you're trying to solve for, then that can be a very useful strategy. So I hope you guys enjoyed that. That's all I'm going to do. If you have any other questions or comments, feel free to post them in the comment section of this video. Tried to go over a few simple examples. Hopefully it was helpful for you to learn how to do this kind of stuff. And I'll see you next time for another video. Goodbye!